Now we're going to take a bit of jump material and we're going to talk about a completely different type of concept. So this unit's going to be predominantly about how we can organize information, how we can display it in other forms, and then also how can we use data to talk about measures of average and just find useful information from it. So the first section we're going to go through is about how to work with Venn diagrams. So probably at some point in your life you were in an English class and you had to create a Venn diagram. And if you remember anything about that, it was typically like, here's two characters, then you had two circles and there was overlap between them. In the middle, you would put characteristics or things they had in common. Then on the outside was stuff that was unique to those people. Same idea holds with math. So we're going to see how we can use Venn diagrams to display different information if there's overlap. And then also how can we work with operations within those different things. So before we begin going through all of our definitions, we're going to work with an example. So here we're told an animal sanctuary houses a variety of animals. To understand the workload of each doctor, the director looked at which type of animals were treated or not treated by various doctors. This Venn diagram shows the information for two of the doctors. So we're going to answer a bunch of questions for it, but before we even get to that, I want to talk about how this Venn diagram works. So we have these two circles, and in this first circle, we're told these are the animals that are treated by Dr. Aoki. Then we have this other circle here, which are the animals that were treated by Dr. Price. And then there's that section in the middle, which is the overlap. So those are animals treated by both of these two doctors. Now, however, if you notice, there's some animals here off on the outside. That's because this bigger box is representing all of the animals that are housed at that facility. So at this animal sanctuary, there are all of these different animals, and you could list them all out. This animal sanctuary has elks, rabbits, horses, goats, llamas, dogs, otters, and koalas. But if you notice, there's two that are outside these circles, meaning they're not treated by either of these two doctors, okay? So all of these animals that I just listed are the ones that are in consideration for this particular problem, right? This is something that we'll talk about in a second. It's called our universal set. It's every single animal that's housed here, okay? So we're going to answer 3 questions. The first one asks, how many animals were treated by Dr. Aoki? So for that, I'm going to look at my circle. Here are the ones that are treated by Dr. Aoki. And I'm going to look at everything that's in this circle. So you can list them out, but it just asks us for the number. So in this case, there are 3 types of animals. If you want to list them specifically, those animals are elks, rabbits, and horses. Okay. Question B asks us how many types of animals were treated by Dr. Aoki or Dr. Price or both. And this is where you have to be careful with the language. So if you think of the word or, it can mean one or the other or both. So if your waiter asks you, do you want a soup or a salad? You can still answer, I want both of them. Okay, so the or is kind of more free, I guess is the good way to kind of describe it. You can take a bunch of different options within it. Another word you're going to see frequently is and. How many animals were treated by Dr. Aoki and Dr. Price? In that case, that would be very selective, and it's the ones that are just treated by both of them. So just pay attention to the words that are used for you, for each problem. So in this case, because it's how many types of animals were treated by Dr. Aoki or Dr. Price or both, that would be all of the animals housed within these 2 circles. So again, it just asks for the number. That's 1, 2, 3, 4, 5, 6 animals in total. You never double count a piece of information. If you want to list them, it's the same ones we listed above: elks, rabbits, and horses, with the addition of goats, llamas, and dogs. Okay. And then finally, we have one last question. It asks which type of animals were treated by neither Dr. Aoki nor Dr. Price. And that would be these two animals sitting on the outside. They're animals, again, that are in the sanctuary, but they're not inside either of these circles, so they're not treated by the two doctors. In this case, it specifically asked which types. So those types would be otters and koalas. So now that we have a little bit of a feel for how a Venn diagram works, we're going to talk further about this concept of sets. So a Venn diagram is used frequently in studying sets. Okay? And really all a set is a list of objects. You have a set of classes. Those are the classes that you're taking. There is the set of students taking this course. You could go into the people's page and you can get a list of everyone who's taking the course. So it's just a collection of objects. That's all the word set means, okay? When we talk about a set, there's a couple different ways that you can write it. You can use a description. So that's exactly what I just did. I verbally described the stuff that was inside there. But the most common form is roster form. And that's exactly a roster for a class. It is just listing them out. So what we do to list in roster form is we put a curly brace at the front. And what this curly brace does is it starts the set. You don't want to just list it. You have to say this is the set of, and then you put everything on the inside. You'll do a curly brace at the end to finish the set. So just like we have proper notation when we're writing a sentence, you capitalize the first letter, you put a period at the end, the curly brace starts the set, the curly brace ends the set. And then for an example, I'm going to list the US states. That is a set. That's its descriptive form. In roster form, putting those in alphabetical order, the first state is Alabama. And then the next alphabetical one is Alaska. And I'm clearly not going to write all of the states out. The pattern just continues. And the last state alphabetically is Wyoming. Okay. So the reason I chose this is also these ... dots just mean continue the pattern. So if there's a starting and ending, you put them in the middle. You can also have the ... dots at the end. So just to kind of give you another example, say you're listing all of the natural numbers, 1, 2, 3, 4, all of the counting numbers basically. You cannot end this set. It just continues on forever. So those ... dots are an indication of that, okay? So be careful when you're entering stuff in. You do have to enter these curly brace because when you're talking about any set. If you don't, it's not the right notation and it's going to mark you incorrect. Okay. Now within the set, any single object that you have, so Alabama is a member of this set or it's contained within it. Alaska is a member of the set of US states. Wyoming is a member of the set of US states. And same thing here, all of these numbers. 1 is a member of this set of counting or natural numbers. So we can use either one of those words. Each object in a set is called an element or a member. Okay. So kind of going back up here, if I was asking you the set of animals that were treated by Dr. Aoki, it would be exactly this list. And again, I would put curly braces around it. This is the set of animals treated by Dr. Aoki. This set here is the set of animals that were treated by Dr. Aoki or Dr. Price or both. And then this set here is the set of animals treated by neither of the doctors. Okay. Now, when you're talking about a particular situation, you have a list of objects considered for that problem. This is called the universal set. So it's denoted by the letter U. So if we were to go back up here, the universal set is all of the animals housed at this particular sanctuary. So it would be the elks, the rabbits, the horses, goats, llamas, dogs, otters, and koalas. These are all of the animals in consideration for this particular problem. Okay. And then you could say the set of animals treated by Dr. Aoki is this list. The set of animals treated by Dr. Price is this list. And then we have those little ones falling off on the side. Right? So that is our universal set. That means everything should find a home in my Venn diagram that's in this set U. Now, it's possible, like in the case that I don't have anything overlapping or there's nothing in common to two sets, that we need to talk about something that has no elements. So the empty set, which is denoted by a 0 with a slash through it, is the set with no elements. So it is empty. Okay. So let's try an example. Let's construct a Venn diagram illustrating the sets below. So they give us the universal set U, and then we have these two sets Y and Z. So U is going to be this entire box, and then I have these two smaller sets Y and Z. So that means the numbers 1 through 8 all need to be placed in the diagram. You can really do this however you like, but I think it kind of makes sense to work in the middle here first. So what I'm going to do is I'm going to figure out what elements are members of both Y and both Z. So going into my two sets, they both share the number 1 and they both share the number 4. So those two have to go smack dab in the middle here, okay? And then I'm also going to simultaneously mark them out of U because they found a place somewhere in my diagram. Then from here, you can kind of pick whichever one you want to work with. I'll start with Y. So these members in here should be part of Y, but not in Z. And that would be these two numbers, 3 and 6. They have to belong in Y's circle, but they do not go in the middle because they are not in Z. So again, gonna mark off 3 and 6 for my universal set. Next up then, I'll go ahead and figure out what gets placed here. So looking at Z, the only number that hasn't found a home yet is 8. So that's gonna go right here. And again, I'm going to mark off that it found a spot. So I filled in my two circles, but I still have not finished my Venn diagram completely because there are 3 numbers here that do not have a home. So 2, 5, and 7 fall nowhere in Y and Z, but they still are part of my universal set, so they have to be placed in my diagram. So in this case, we just put them off to the side. They do not fall into the circles, but they still are an important component for this problem. Okay. So now that we have a little bit of familiarity with the terminology, we can talk about operations with these things. So I'm going to give you kind of just the definition or explanation for each of these, give you the symbol, and then I'll draw you a little picture with it as well. So if you're finding the set of elements common to A and B, this is called the intersection of the two sets. So the way we write this is if I'm looking for the intersection, that's just the overlap, the symbol we're going to use is an upside down U. The way you can think of this is the word end. What is in A and in B? Okay. So picturally, if we have our Venn diagram, if here is A, here is B, and let's zoom in on this to make it a little easier. The intersection is the piece right here in the middle. So it's that center component. Right? Now, if we're looking for the set of elements that belong in A or B or both, this is called the union. Okay. The way we write this one is we're looking at two sets A and B. The union is a giant U. So this is representing the word or. So the way I like to think of it is you think of the Union of the United States. It's all of the states coming together to build this one big country. You can also think of it as the union of marriage. Two different people joining their lives together, everything becomes one. So to give you a little picture again, so we don't have a ton of room in there. If here's A, here is B, the union is both of these circles. So anything within the two, it melds them together. The last one is specifically for one set. If you want to find the set of objects in U that are not in A, this is called the complement. So the way we're going to indicate that is really with kind of like a parenthesis, but or an apostrophe, but it's a straight line. This is meaning not in. Okay. So again, to give you a picture, if here is our Venn diagram, here is set A, here is set B. The complement of A is everything except A's circle. So it's all the stuff not in A. Okay. Now it's absolutely possible that you're going to do a couple operations together. So I can take the complement of A union B. I could also do the complement of this. You can also just do A intersect B complement. So there's a lot of different ways that you can do. The other thing, depending on the book that is being used, instead of writing a prime like this, you might see a little C at the top to stand for complement. It's really just book specific. Okay. The way you work through these is just like you work through your order of operations. So if you were to take A union B complement, you'd find the union first and then find the complement. So to show you just with these pictures, this is A union B. So then if you were to find the complement is everything except that. So it would be all the stuff out here. So this would be A union B complement. Okay. So again, order of operations, you find the thing in the middle first, you do the parentheses, and then you take care of those exponents. Right? So let's try some examples with this. The sets C and D are subsets of the universal set U. These sets are defined as follows. So here is U, and then we have these two subsets. Subsets just means they're portions of U. So if you look, Q, K, X, and Z are all inside U, and same thing, K, M, and X are all in here. So they're just picking portions of U. Okay. First thing I'm going to do is I'm going to construct a Venn diagram. So again, I'm going to label everything. Here's my universal set, and then I have these two smaller sets, C and D, that fall within U. I want to start with the middle, so I want to find the overlap of C and D. That would be K, and then also X. That's inside both of these sets. So I'm going to cross them off from U. They have found a home. Now I have Q and Z that are part of C, but they are not inside D's circle. So again, going to cross those out of U. They found a home. Then in D, we just have M to place, so it goes off to the side. And then we have a single letter remaining, R goes on the outside. Right? Now that we have our Venn diagram, I'm going to utilize this to then find these sets. And I'll probably add some extras in here just for some good practice. We're going to start with the intersection of these two. So C intersect D. So again, this means end. It has to be in C and in D. So the intersection, because it kind of looks like an N, is that overlap. Okay. So again, you have to be very careful how you write this. You don't want to just write K and X. This is a set. So we're going to go ahead and we're going to put curly braces around it. Okay. So C intersect D is the set of elements K and X, these two pieces here. Okay. Now for this next one, you have to find C union D complement. And again, thinking of your order of operations, you would take care of exponents first. So I'm going to start by finding D complement. Then I'm going to find the union. So if we find D complement, again, this is a set. That means everything not in D. So what I'm going to do is I'm going to black out D circle. These are the things in D. I'm going to take everything outside of it. So that would be Q, Z, and R. This is D complement. So Q, Z, and R are the elements not in D. Now what I want to do is I want to union this with C. So just to refresh, C is the elements. I'm just going to copy it down. K, Q, X, and Z. Okay. So the union is going to join these two together. So all that means is if it's in one of these, it's in my union. I meld them together. So I'm just going to copy everything I have from D complement down. And then I'm going to copy all of my new stuff from C. So Q, Z, and R, Q, Z, R. Then I'm adding in K. I don't need to rewrite Q because it's already in there. X is not listed yet, so we copy that down, and then Z is already in there, so again, no need to double copy letters. So it will be these 5 elements. Okay, so all you do is then list those two together. Let's try one more that I'm going to make off the fly. We'll call this D. Let's find C union D complement. Okay. So this one's a lot harder. It's got a lot of stuff going on, but we have already found the thing in the middle. That's exactly this back here. Okay. So without going through and working with this picture, what this means is C union D complement is this list here. I want to take the complement of that. So that means looking at all of the objects that are listed, I want everything except these. So looking at my chart, Q is in here, so that's not in this. Z, R, K, and X. Okay. Those are all of the elements in C union D complement. So that means the complement of that is the singular element M. Okay, because that's the only one not in this list, right? So that would be how you do it without looking at the Venn diagram. But what I'm also going to show you is picturally how we go about this. Okay, So looking at C, I'm going to highlight this. This would be C. I union that with D complement. So that means everything except D. So that would be all the stuff on the outside here. And then it would also be this stuff. So you see it gets double shaded. Okay. Anything highlighted then is this union. And that's exactly what we have listed here. So the complement of it is the stuff I don't have highlighted yet. That is C union D complement. Okay. So give it a try with these. It's going to take a lot of practice. These are a hard concept though, but do your best with it. Take it piece by piece and remember your order of operations. So your parentheses tell you work inside here first. Then you're moving on to exponents, so you have to find this. And then that union and intersection, it really doesn't matter. You can consider it multiplication, you consider it addition and subtraction, whatever you want, but both of those are similar to each other. Okay. So let's do one last more example where we're going to be given the results of a survey, and we want to use this to figure out some pieces of information. So they tell us a drug trial had 337 participants. A survey was taken to determine how many had nausea as a side effect and how many had drowsiness as a side effect. The Venn diagram shows the results below. Okay. So one thing you have to be careful about, because you're going to have to build some of these, if you add all of these together, it's going to exactly equal 337. Because the 337 participants fit in exactly one of these categories. Either they're out here, meaning they didn't have these, they're in the middle, meaning they had both, or they're over here, meaning they had nausea as a side effect, but they did not have drowsiness. And then same thing for the 77 that are right here. So be careful when you have to build the chart where you're putting pieces of information. So starting with this first one, we want to figure out how many of the participants did not have nausea. So if I'm looking at the have nausea circle, that would be these people here. So the ones that did not have nausea would be these two categories, the 77 and the 73. So if we add those together, exactly 150 participants did not have nausea. Then the next question asks how many of the participants had nausea or drowsiness or both. And remember, or means as long as it has one, it's in the or. Okay, so that would be anything that falls within these circles here. So 119 people just had nausea, 68 had both, and 77 just had drowsiness. So adding these together gives us a total of 264 participants. And then the very last question, how many of the participants had nausea but did not have drowsiness? So that would mean it has to be within the nausea circle, but outside the had drowsiness. And that's going to be exactly 119. Okay. So just be careful when you're going through these problems, really dissect the English. When you're building it, when you're given the survey results, it's going to be a lot more complicated. So try your best with it. If you have questions, let me know.